Okay, these are the formulas that we use to show some calculations on our system that we designed. At the top you'll see the motor specifications. For number one, we just did a basic figuring out how much our horsepower equals into watts. For the next calculation, we figured out how many amps the motor is drawing, and as you can see up here, although the nameplate already gives us the current draw, we kind of show the math behind that and a way to verify it. We'll skip 3 for a second because we're going to need to show you that one in a second. On problem number 5, you'll see we calculated the annual cost to run the motor. So once you do the calculations, it costs about $588 per year to run this motor at 60 hertz non-stop. Going back to number 3, I did a reduction cost savings, which is, again, one of the nice things about a variable frequency drive is you can reduce the hertz of it and actually save money based off your needs. So I calculated out for a 50% reduction, which is the most you're going to save on a frequency drive, which will run it at 30 hertz. So you'll see down here my annual cost at 60 hertz is $588. Once you factor in the 50% reduction to 30 hertz, it actually equals out to an 87.5% savings, and then you end up only spending $73.51 annually. Okay, continuing on, this is just a quick overview of our diagram of how we have our system set up. You can see in the top left corner 230 volts AC single phase coming in, going into overcurrent protection here, which then travels up, goes into our variable frequency drive controller, and actually it will convert it over and send it out in 3-phase 240 volts up, over, into our motor. Another nice thing about variable frequency drive controllers is the fact that you can actually have quite a bit of cost savings. Running this thing at 60 hertz, you're going to get no cost savings, but as you start to turn this down, your cost savings increases exponentially. Running this at 30 hertz is a 50% reduction, which will actually give us about an 85 to 87% cost savings to run this motor. So that's also another good thing to have for these types of systems. Okay, this is our final exam project for electrical and motor control circuits. What we have going on here is a real basic variable frequency drive system, using this PowerFlex 4 system to adjust the frequency of this drive here. In the circuit you'll see that we have a couple of circuit breakers down here for current overprotection. In a second here I'll show you exactly how the system works. Over here you'll see that we have our potentiometer, which is actually adjusting the hertz of the motor, which will adjust the speed. We have our power button here to start the system, and this button here to adjust whether we're going forward or reverse. Okay, now that the system is activated, I can use this to adjust the hertz or the frequency. Which in turn is also adjusting the speed of the motor. Okay, we can reverse it and go forward by pressing this button here. Okay, so another thing that we got going on here is our power coming in. Although our motor is running under its low voltage setting, which according to our stamp is 230 volts 3-phase, we are actually using 240 volts single phase, sending it into the variable frequency drive controller and having 3-phase 240 come out of it to power the motor. So this is just a general overview again of how you can use a variable frequency drive controller, and it's about it.